Hello everyone, and I welcome all of you to online study for you, a complete placement solution. This is Pratik Srivastava here, and in our today's video, we are going to solve Accenture actual question asked in the recent examination. And friends, this video will be very helpful for your upcoming examination. Here we have covered cognitive, and we have covered C programming. We have also covered networking and common application, pseudocode and coding. So we have covered like a complete set of question. This will be very helpful. Now let us start solving with the question number one, and I wanted to tell you friends, now the question which is getting asked is little tricky, and more number of C programming question is getting asked, to be prepared according to that. Question number one: which of the following response figure should be used to replace the question mark? Now let us try to analyze. So if you'll see the figure friends, the first figure what we have is hexagon, right? So the first we have hexagon because we have 6 sides. Then we have pentagon because it has 5 sides. Then we have here square, so because we have 4 sides. And then we should be having triangle, right? Okay, because we have to find out the missing one. So triangle. Now it's very clear that A and C cannot be your answer, right? Okay, triangle will have 3 sides. Now so friends, if we'll try to analyze once again, then so either B or D will be your answer. Okay, now so again once again we'll try to analyze. So hexagon inside the figure has 1 side less. Okay, so it has 5 sides. Then pentagon inside the figure has 1 side less. A square figure inside that 1 side less. Triangle definitely 1 side less. So option D will become the correct answer, not B. So you have to mark this particular answer for this particular question. Friend, question is simple. The only thing is practice is required. Now choose the missing phrases from one of these options. We have 1B, we have 4C, we have 9E, we have 16H, and then we have what? Okay, fine. So if we try to analyze friends, this is 1 square is 1, then 2 square is 4, then 3 square is 9, then 4 square is 16, and then 5 square will be 25. Okay, so option A and D can be easily eliminated. Now out of these two, you will be your answer B, C, E, H, and what will be next, right? So here if you'll see, the gap is 1, B, C, C, D, E, the gap is 2. Here E, F, G, H, gap is 3. Then H, I, J, K, and then L. So the gap will be 4, it will be L, right? Okay, so 25L will become your answer, and here you have to mark option C is the correct answer, right? So once again I am repeating the same thing. The level of the questions in the exam will be easy. The only challenge you will face is if you do not have done the enough practice, then you will face problem in the exam. Answer the question based on the given statement. Many of the students had given the wrong answer for this. How many players are there in the ground? Statement 1. The ground has 50 boys. So they have given the ground has 50 boys, but they have not given the number of girls. So we cannot tell how many players were there from the statement 1. Statement 2 says the ratio of girls to boys. So the ratio of girls to boys is 2:3, right? Okay, now so ratio has been given, right? But nothing, no other information in statement 2 is given. So statement 2 alone also cannot tell you the answer. So 1 and 2 option is eliminated, right? Now we have the option to combine. So friends, I have told you, whenever the options, the data is given in terms of ratio, you can write down in terms of value. So 2x is number of girls and boys is nothing but 3x, right? Okay, and the number of boys they have given is 50. So 3x is equals to 50. So x will be equal to 50 by 3. So number of girls 2 into 50 by 3. So number of girls 100 by 3, that means 33.33. So the girls cannot be in the fraction. So even with both the statement, we are not able to solve. So my answer will become neither statements is sufficient, right? Okay, friends, I will tell you, one more way. So if see, suppose the ratio, if the ratio they would have given 3:2, then we would have easily solved this question, right? So instead of 2:3, if they would have given 3:2, right? Okay, so girls is to boys ratio is 3:2. Now boys we know, so boys is what? 50. That means how many times? 25 times. So here girls will become what? 25 times 75. Then we could have easily told, sir, the total number of players will be 125. But Because of the ratio, we are getting the number of girls in fraction, and that's the reason we cannot solve this question, right? So friends, practice very, very important and dealing this type of question. All right, friends, many of the students told that, sir, they have already cracked this cognitive pseudocode and coding round and they have given the interviews, right? And that's because of this particular Accenture crash course, right? Because friends, see, 500 rupees is not a big deal. You also know, within one day you spend 500 rupees, but this 500 rupees course of Accenture will also help you in another exam, and lot of practice you will get. See, if you go to content, you can see, so there are, reasoning videos, verbal ability, coding, pseudo code, MS application, test series, and the previous year questions, I mean the recent question also we have done. So this crash course is more than sufficient for you to crack the Accenture examination. And I'm telling you, you can check the comments on the videos, right? So don't regret later. 500 rupees is not a big deal, right? So get the course and start your preparation, right? Okay, fine. Now, next problem, if you'll try to see, so in a certain code language, land is, friends, all the tricks and techniques, everything has been given in the course. Land is written as 31, turn is written as 73. Then how food will be written as, okay? Now, so friends, I have taught you in this particular course, I have taught you the tricks, okay? So if you'll go here and if you'll try to see reasoning videos, so alphabetical series, okay? Where is it? So coding and decoding is here itself. Okay, yeah. So coding and decoding. So this is 1 hour and 10 minutes video. There I have told you the tricks, like lunch, SBI Bank. So they will go for the lunch at 12. A is the first letter, November 14th, Children's Day. D is nothing but the fourth letter. Now if you add everything, 14 plus 18, 19, 31. T20 match. U under 21. R, how can you write? R we can write like this, 18 and November 14th. So 81943 and 3 to 5 plus 2 7, 73. So basically you have to add the positions of the letter. F fix 6, O O is 15, O is 15, D is 4. So this will be 30 and 10 40. So 40 will become your correct answer, right? So if you have the trick in your mind, you will be easily able to solve the question in the exam. Next, A to Z, okay, B for Y, T8W, okay, and F12U. Very simple question. So basically what has been given, opposite letter has given, right? So A to Z, I have taught you. Boy, opposite letter of B is Y. DW, right? So here DW, Mountain Dew, right? So DW, right? Here. And then FU. So after D, what will come? E. So for E, I have told you electric vehicle, right? For F, I have told you fun. So F opposite will be fun. Electric vehicle, EV, E opposite will be V, right? So EV, option A is the correct answer. We do not have to look at the middle positions or middle numbers, okay? So you can mark option A is the correct answer, right? Okay, fine. Then we have 2Q5, 7P7, 1409, 23N11, 34M13, right? Okay, next. So 5 plus 2, I will use another pen here. So 5 plus 2 will be 7, 7 plus 2 will be 9, 9 plus 2 will be 11, 11 plus 2 will be 13, 13 plus 2 will be 15. So my last letter is 15. Now, why do I need to check for the further things, right? So I am very clear that the last will be 15. Option C will be the correct answer. So friends, see, practice and how should be your approach towards the question. That is what I am teaching in this particular crash course. And that's the reason I am asking you to take, so that you don't regret later that if I would have taken the course only for 500 rupees, I could have easily given my Accenture interview, right? So that is the reason this course is there, okay? So that you get to know how you have to solve the question, how easily you can solve the question in the exam. Choose a figure which is different from the rest. So in the first figure, you see both these points, right, are on the same side. Here the points are in different side, different. So in option A, both this particular points you can say, or circles you can say, is in the same line. Now, so next is, this is a very different question. Let us try to understand. So if motorcycle, so if motor if motorcycle is written as CLEORCYMOT, then how pine, then how pineapple, okay? So then how pineapple coded in that language? Okay, no problem. So here try to understand. So friends, the first three letter MOT, right? So the first three letter is moved to the last, and the last three letter is moved to the first. That's all. The first three letter is moved to the last, and the last three letter is moved to the first. So PLE. Okay, fine. And then ORCY, the middle letter is kept as same. So the middle letter is kept at same. That's all. But here also practice is required. PLE, EAP, PIN. If you have good practice, then no problem at all. Now, in a certain code language, trucks. So in a certain code language, trucks is coded as WPXANQ. Okay, now MOPERS. Then how mopers will be written in that code? First, try to analyze here. So for analyzing, you need to remember the position. T20, R18, under 21, C3, Kings 11, S19, right? S, how can you write? So S you can write like 19. W, right? So UVW, it is 23, Prince 16, X 24, A1, November 14, Prince 16, and Queen 17. Okay, now you see the first, here it is plus 3, here it is minus 2, here it is plus 3, here it is minus 2, here it is plus 3, here it is minus 2. Okay, now so same thing here we have to do. So basically M is nothing but 13, E J O is 15, Prince 16, E5, R18, and S19. Now so plus 3, 13 plus 3 will be 16. So 16 will be what? Prince 16. Okay. So starting with P, there is only one answer. Anyway, minus 2. So here if you'll see 13, 13 is nothing but M. So PM. And then 16 plus 13, 19, which is S. E5, 5 minus 2. 5 minus 2 is 3, C. And then 18 plus 3, 21, under 21, U. And 19 minus 3 is 6, Prince 16. So PMS 19 minus 2, sorry, 19 minus 2 is 17. So Queen 17. So PMS CUQ. So all this we did not have to calculate. Only 13, 13 plus 3 is nothing but 16, and Prince 16. That means option A will become the correct answer, right? Okay. Now, which loop is guaranteed to execute only one time? Okay, at least one time. So which loop is guaranteed to execute at least one time is nothing but do while. Friends, so with a do while loop, the condition is not evaluated until the end of the loop. Okay, because of that, a do while loop will always execute at least once, right? So with a do while loop, the condition is not evaluated until the end of the loop. Because of that, a do while loop will always execute at least once. So the condition will be executed at the end. So that's the reason the answer will become do while. Now, the continuous statement is not used. Okay, the continuous statement cannot be used with. So the continuous statement is not used with the switch statement because it can be used within the while loop, do while loop, or for loop. So this will become your answer. The continuous statement cannot be used within switch statement. Okay, now Microsoft Word, Microsoft Excel, and Microsoft PowerPoint are part of Microsoft Office suite. So in your laptop, you can find Microsoft Office suite, right? In that you will be getting Word, Excel, and Microsoft PowerPoint. How can you replace text in a documents or text editor? Many of you will think control plus R. No, it is friends control plus H if you want to replace a text in a document or a text editor. Okay, now friends, so pseudocode and coding questions will be done by Nitin sir. So let us start with pseudocode and coding question. Before that, friends, once again, so get this course, don't regret later, right? Okay, so this is sufficient. You will get enough practice, and subscribe to our YouTube channel so that you will be getting a lot more videos. Thank you, take care, and all the very.
So hello and welcome to Online Study for You, a complete placement solution. So in this video, we are going to discuss some of the Accenture pseudocode problem and the coding problem as well, which is asked in recent Accenture examination. Okay, so let's first start with the pseudocode problem. Then we will move to the coding problem. Okay, so our first problem that we are going to solve is this. So here a pseudocode is being written. Now we are going to solve it. Okay, so you can see, okay, here what is given. In the first line itself, there are three integer variable is been given, which is pp, qq, and rr. Okay, pp, qq, and rr. Now, the initialization of all the variable is been given that pp is initially assigned to 6, qq is initially assigned to 6, and rr is initially assigned to 4. Now, move to the third line. The third line itself says that rr is equal to 12 and 11. Okay, so basically what it is, because first we have to execute this because it is inside a bracket, so it is given the most priority. What it is a logical and operator. Okay, it is, sorry, not logical, my mistake, it is a bitwise and operator. Okay, bitwise and, it is denoted as this. So let me write the functionality of bitwise and. So what actually bitwise and will do? Bitwise and will take one by one bit position of every two numbers. So here the two number which I am comparing here is 12 and 11. 12 and 11 are the two numbers. But these two number currently it is in form of decimal form. But to apply bitwise and into it, first we have to convert the decimal into what? Binary. So how we convert any decimal number into a binary number? There is a technique. Let's say we are taking the number 12 to convert it from decimal to binary. So first we take 12 and divide it by 2. Now it will be divided in 6 times, and the remainder, we are writing the remainder here. So when we divide 2 upon 12, then remainder will be 0 and the quotient will be 6. Again divide this quotient with 2 again. Now again the remainder is 0 and the value which is divisible by 6 is 3. Quotient will return as 3. Again divided by 2. Now when I divide 3 by 2, then the remainder will become 1, because when you divide 3, 2, so it will be divisible by 1 time and the remainder is coming as 1 itself. Okay. So now this remainder will come here and now the quotient will become 1. And now we stop. So we have to stop when our quotient, which I writing here, will become 1. So now what I have to do, I have to write this from this to this in the sense of left to right. So first it will be written, first the bottom one will be written, then the upper one. Going from down to bottom, we have to write. So first this will be written 1, then now this will be written 1, again this will be written 0, and now this will be written again 0. So what it is basically a binary form, okay, of this. Binary form of this. So in this way, we are going to convert every decimal number into binary number. Now let's take another number also, to 12, 2, 5, 2. Okay, sorry, let me write a remainder here also. So 1. Again, quotient will be 5. Again, when do we divide 5 by 2? So remainder will be 1 and the quotient will be 2. And now when we divide 2 up by 2 only, so remainder will be 0 and the quotient will be 1. So when quotient will be 1, we stop. Now we have to write from top to, sorry, bottom to top. So first this one will be written, again the 0 will be written, again this one, and again this one. So what it is basically a decimal binary form of 13. Understood this? So now in this way, we are getting the binary form of these two number. Okay. So let me take this two number. So I am getting here 12 and 11. Okay. So binary form of 12 is getting 1100. I hope this is correct. 1100. Yes. And binary form of 11 is coming as 1011. I hope you understood this. Now let's take it. So now we are going to take bitwise AND of these two. So bitwise and say that when one, both are 1, then I get 1. Else, if any of them are not 1, let's say first one is 0, or the second one is 0, or the of them are 0, in all this case, I am getting you the value as 0. So bitwise and will say, if both are 1, then only I get you 1. Otherwise, I will get you 0. So let's take this value. So 1, 1, 0, 0. This is the value of 12 and the value of 11. I am writing corresponds to that. Okay. And taking AND of both. Now, 1, 0 will get me what? Because I am taking bitwise AND here. So 1, 0 will get me 0. Again here, 1, 0 will get me 0. 0, 1 will also get me 0. Because any of them are 0, then I get 0. But here, both of them are 1. So I am getting 1 here. Both of them are 1. So I am getting 1 here. Now, I getting this new value, but this value is in binary form, but I have to convert into decimal form because I am operating here in this pseudocode in decimal form. So how now? We learned about how to convert a binary to decimal to binary, but now we are getting that how we convert a number from uh, binary number to decimal number. Okay. So let's take this number. So to convert it from binary to decimal, we have to follow some rules. The rules A, we are starting from left, sorry, right to left. Understood? Right to left. And the rightmost index is 0. This index, let me change the color. Okay, this one is fine. So this is 0. This is first index. This is second index. This is third index. So on. We are incrementing from right to left. So now this is called as index of that place. Okay, or you can say place value or the place, anything you can say. Now what we have to get, we have to write the formula is the value at that position, the value at position, because you can say it as also position also, value at position multiplied by 2 to the power position. I hope you understood. So for that, for getting this value, okay, for getting this value here, what we are going to do, so this is currently 0th index and the value is 0. So when value is 0, then obviously whatever value it is, it doesn't matter because this is 0. So all the value is 0. So for this position, 0 into 2 to the power 0, which is 1 into 0 will be 0. So from this position, we are getting the value as 0. Now we are checking for this position. Okay. Now from this position also, we are getting the value as 0. Now from this position, also we are getting the value of 0 because the value at the position is itself 0. So whatever the value of this 2 to the power position will be, it doesn't affect my total value. Okay, because 0 is multiplied by any value will ultimately become value as 0. Now when we come to this third position, so now this position has value 1. So we are getting 1 into 2 to the power. What is the position of that value? 3, which is 2 to the power 3 with what is 8. So 1 into 8 will be 8. So now 8. So we are adding all the value of every position and adding them all, and we are getting a value as 8. So it is the decimal form of this value, that is, this is the decimal form of 1000. So I hope you understood how we convert a number from binary to decimal and decimal to binary. There is a trick also to solve this problem, which I have already explained in the previous video of Accenture pseudocode problem, which I have made uh, 10 to 10 days ago. In this YouTube channel, it is being posted. So you can go and check that video as well. Okay. Now, let's come down here. So this is approach. So what value we are getting after 12 and after getting 12 and 11, we are getting the value as 8. So now 8 will be returned here. So I hope you understood. So 8 will be returned here. And why it is taking me so long to solve this problem? Because I am teaching you. I am considering that you don't know the concept. But when you practice this concept, it is hardly taking you a 10 to 15 seconds to solve this. Okay. So now this whole value will get me 8. And the PP value, what is PP value? We are checking from the table itself. So PP value is 6 currently. So 6. Now 8 plus 6 will be 14 and 14 will be assigned to my RR. So RR will now become 14. Okay, or I am writing down here. So RR is now 14. Now we are going to check for the next value itself. Now the next condition is it is written as this is done. Now we are getting here QQ equal to PP plus QQ plus RR. PP, what is PP? PP is 6. QQ, what is QQ? QQ is 6 and RR, what is RR? 14. So 6 plus 6 plus 14 ultimately will become 26. So, and it will be assigned to QQ. So now my new value of QQ will be 26. Now, again, there is one AND operator. It is PP equal to 10 and 8. Sorry, 10 and 8 plus QQ. So first we have to get the value of 10 and 8. So let's come here. Okay, 10 and 8. So first we have to convert this 10 and this 8 to bitwise bitwise value, or you can say binary value. So 10, how will we change? Divide, just divide, remainder right here. 0, 5, 2, remainder will be 1, 2 times, again 2, remainder will be 0 and 1 times. And now we are writing from here to here. The value of 10 will be 1010. I hope you understood. Now going for 8s in the same way. 2, remainder will be written here 0, 4 times, 2, 0, 4 times, 2, 2, 1 times. So value of 8 will be 1000. And we are also checking it from here. This is the same value of 8 what we are getting. So this is how we change a number from decimal to binary. Now after changing, what we are going to do, we are to taking the bitwise AND of both. So 1010 and 1000, and we are taking bitwise AND of them. So what is bitwise AND says? Here I am written the table. If both are 1, then only 1. Otherwise, if any of them are 0, then we are returning 0. So now you can see both of them are 0, so obviously 0. One of them are 0, so 0. Both of them are 0, so 0. And here one of them are 1. Both of them are 1, so it is 1. Now it is, what's the value it is? It is the same value of 8, because you can also see this is the value of 8. So when we convert this to binary, sorry, to decimal, this binary number to decimal number, then we get the value as 8. And how to convert, I have already explained you here that how to convert. Now, so the value returned from these two will be 8. Understood this? Now, this QQ, what will be this QQ? QQ is currently 26. So it is 26. So 26 plus 8 will become eventually 34. And this will be stored in my PP. So my PP will now become 34. Now what I have to do, I have to just print addition of PP plus QQ plus RR. So add PP plus QQ plus RR. So current value of PP is 34 plus QQ is 26 plus RR is 14. So when we add them both, so this will become 40 and 40 plus what? 34, you can say 74. So this will be the correct output. 40 plus 34 will be 74. So option C is the correct for this question. Now I hope you understand this pseudocode. Now we will move to the next pseudocode. Okay. So this is the second pseudocode that we are going to solve today. And here also the first line is the just initialization of three variable, that is PP, QQ and RR. And the value initialized to PP is 5, value initialized to QQ is 6, value initialized to RR is 4. Understood now? So this line is also done. Now we are moving to the third line. So the third line says QQ equal to PP plus QQ plus QQ. So PP value currently is 5, QQ currently 6, and again QQ is 6. So 6 plus 6 plus 5 will eventually will become what? 17, because 6 plus 6 will be 12 plus 5 will be 17, and it will be stored in QQ. So QQ is now become 17. Now here one loop is written. So try to understand this concept very well, okay? Because this kind of problem is being asked you in very much in Accenture examination. So here loop is been given and loop is been running from where? The variable which is running on the loop is RR, and the value of RR is ranging from 3 to 6. So now here you can see the value of RR is initialized to 4, but now because RR is initialized to a new value which is starting from 3, so 3 will be first initialized to here. Understood this? Okay. And now what is being written here? So you can see one statement is written that QQ equal to QQ. What is this? It is a bitwise XOR operator. Okay, I will be understanding you this also. Bitwise XOR operator. So I have already learned about, you have already learned about the bitwise AND, but now we are learning about bitwise OR also, XOR also. Okay, so let me write it here. So it is actually bitwise XOR. So I already told you, because to applying any time bitwise, any bitwise operator to any decimal value, we have to first convert into the binary values. Okay, and how you convert a decimal to binary, I have already explained that. Now after converting this, bitwise XOR also have some rules. Okay, so bitwise XOR say, it will say if both bits are different, then returns 1, else if both are same, return 0. Okay, what it is means? So let's take an example. Let's check if one is, first one bit is 0 and other bit is 1. That means both of bit are different. Or if first bit is 1 and other second bit is 0. So you can see this is this case. If both of them are different, then we are going to return 1 itself. And if both are same, let me both bit are 1 or both bits are 0, then we are going to return 0. Understood this? Now, what is written here? QQ equal to QQ XOR QQ. So same number is being XORed. So same number is being XORed. That means the same number have same bitwise value. What I'm going to tell you, let's say this QQ value is currently is 17. So whatever the bitwise of 17 is same as the bitwise of 17. Whatever the bitwise 17 is same as the bitwise of 17. Both are the same value. So its binary value is also same. And when we are getting the binary of same value, it will return me eventually 0. So we can simply say when we are taking XOR of same value two times, then we are returning the same value, the value as 0. And another operation, what it is saying, when we are getting XOR of any number with 0, then the same number is being returned, because 0 can't have any alteration in that bitwise operator. What I am going to tell you, let's take another bit. Let's take a bit as 1010. It is a value of any value, any bit value. When we are converting any to binary, this will be coming. Let's assume this. Now, if we are getting it XOR with 0, so you can see both are same, so 0. Both are different, so it is 1. Both are 0, same, so 0. Both are different, so it is 1. So you can see after taking the XOR of same this bit value with 0, I am getting the same number. Okay. So there is a rule for XOR that if we are taking the XOR of two numbers of same value, then they are ultimately will be getting with a 0. And if we are taking the XOR of 0 with any value, it will be getting me that value itself. So 0 XOR QQ will eventually get me QQ, and this QQ will be installed in QQ. So QQ equal to QQ is being ultimately written here. Just it is giving you to lose your time, because if you don't know this trick, then what you will do, you will get the bitwise operator of that number, then taking the XOR of that, then getting the value into QQ, which will be eventually the same value, which I am taking it here, that the value is QQ is equal to QQ, but that will take you the time. And one thing I would like to tell you, that the time is the most important thing in your examination. If you are solving a problem but lost your 5 minutes or 10 minutes, then eventually you are losing some problem which you will able to solve if you save the time in this problem. So this concept is very important for you to learn. Okay, so same value will get me 0, and 0 with any value will get me the value itself. So 0 XOR QQ will get me QQ. So QQ is being itself is installed in QQ. Okay, so this line has no significance because QQ is equal to QQ. You are assigning a value is initially assigned to 2 and you are assigning this to 2. So is this has any significance in my code, or is this change any value in my code? No. So this value has no significance. Now we are getting to the sixth line, because this two line is executed every time that for loop run. Now we are getting to this line. Okay, so this line say RR plus PP plus RR. So RR is 3. Currently the value of RR is 3. Value of PP is what? 5, and value of RR again 3. So 5 plus 3 plus 5 plus 3 will eventually get me 11. So value of PP is, sorry, it will be stored in where? It will be stored in QQ. The value of QQ is now 11. Let me erase it. The value of QQ is now 11, and R will be incremented because in for loop every time it will be incremented by 1. So now new value of R is 4. Again, the value of R is should be less than or equal to 6. So it is less than or equal to 6. Yes. So we are running this loop again. And this condition has no significance because it is ultimately means QQ is equal to QQ. But this line has significance that now my value of R is 4. The value of R is again 4 and value of P is same. So we are doing the same again. So 4 plus 5 plus 4 will eventually become 9 plus 4, 13. Again, we are going to do the same. Okay. Again, the value of R will be incremented by 1. So now new value of R will become 5. Again, we are coming here because it is less than or equal to 6. So we are getting here. This line has no significance, but this line has. So now my current value of RR is 5 and this value of RR is also 5. So 5 plus 5 plus 5, this will eventually will become 15. And now my RR value will become 6. So when we are getting 6, so it will be running also. So RR is 6 and RR is 6. So 6 plus 5 plus 6 will eventually will become 17. Now my RR value will become 7. So when it will become 7, so now it will now not in this range of 3 to 6. So it will now come out of this for loop. But I would like to tell you one thing. So you can see I'm writing it here. So is the this previous value had any significance now? No. So can we skip that for checking? Yes. So how you decide you skip to the last value? If these value is being only dependent upon the value which are changing here or changing anywhere outside of this for loop, then you can take that measure. Okay. But if you are beginner, then you can take, I recommend you to take this approach by going loop every time once so that you will not get an incorrect answer. Okay. So now 6 plus 5 plus 6 will eventually will become 17. And now I come out from this loop. So go down. So I go down to this. This is done. This is done. This is done. And this is also done. So now we come to this line. So now what is it? It is PP is equal to 1 XOR 7 XOR RR. So what is 1 and 1 XOR 7? So let's go down here. Okay. So first we are getting 1 XOR 7. So bitwise value of 1 is only 1. Bitwise value of 1 is only 1 because when you divide 2 by 1, then you get the remainder as 1. Okay. Okay. We don't have to get remainder because the quotient itself remainder. So when this is the rule, when quotient will become 1, we stop. So now there is only one number to print. So bitwise binary number of conversion of decimal to binary of 1 is itself 1. So it is a binary value. Now for 7, we are doing the same approach. 2, 1 will be the remainder and 3 times. 2 again, 1 will be the remainder 2 times. Oh, sorry, 1 times. My mistake. So now it will eventually getting me 1. So I'm printing it from bottom to top. So the bitwise of this will be 1, 1, and 1. Now I'm getting the XOR of both. So I am getting XOR 1. And whenever we are writing any number in the parallel or in the same line, so we start writing from right to left. We are eventually moving from right to left. So this there is only one value which is 1. So I'm writing it here. Now this value. So this value, the rightmost value is go correspond with this. Okay. And the other one is just right placed here. So now the rule says that if there is no value present corresponding to any bit value, so we eventually put the value as 0, 0. Okay. Now we are taking the XOR of both. So XOR operator will say if both are same, then we are taking eventually the 0. And if both of them are different, then we are getting the value as 1. So you can say here both of them are same, so it will get me 0. Both are different, so it will get me 1. And both are different, it will get me again 1. So 1, 1, and 0 will eventually get me what? If I have to convert now this to binary number, if I now convert this to binary number, okay, 1 or 7. If anyone wants to, then you can follow the same rule. For this is the 0th position, this is first position, this is second position. Okay, and there are only 3 positions present. So we are getting what? The value at the position, it is 0 into 2 into the position. It is basically the position. So eventually this is 0, so don't need to check for this, because whenever the value is multiplied by 0, so it will get you 0. So this is 0. Now this place will get me return what value? So it will return me 1 into 2 to the power 1, which is eventually 2. So it will get me 2. Again, what is this place will return me? 1 into 2 to the power 2, which is 4. So it will return me 4. So overall value will get me 6. So if we convert this to the binary number, sorry, the decimal number, then it will get me 6. Okay. But here also one more thing is written. After getting these two, the value is returned me 6. Now I am taking XOR of 6 with whom? XOR of 6 with the RR. And the current value of RR is what? 7. Understood this now. There is one more technique, but let me do it here. So 6 XOR 7. 6 XOR 7. So bitwise value of 6, sorry, or binary conversion of 6, we already know that it is 110. 110. And binary conversion of 7, we already know we are taking it previously at 111. So now we are taking both of them to XOR. 111 and 110, we are taking XOR of them. So here both are different, so it is 1. Both are same 0, both are same 0. Now it is a binary num value, so we have to convert it into decimal. So it is position 0, position 1, position 2. So this value is 1 into 2 to the power 0, because position is 0. So 2 to the power 0 will become 1. So 1 into 1 will eventually get me 1. Now the remaining position don't get me any value because both of them are 0. So it eventually get me 0 plus 0. So the overall value will get me 1. So the decimal value from this binary value will get me eventually 1. So now you can see, come down here. Okay. So the overall value is 1 and it will be stored where? PP. So PP will now will become 1. So now what we are doing, PP plus QQ. So 1 plus 17 will eventually get me 18. So which option is correct one? C option is correct one for this one also. Okay, so I hope you understand this pseudocode as well. Now we are moving to the third one. Okay, so it is a basic if else concept. We are getting into first line here also the variable initialization P, Q, and R. Then initialization of the variable 6, 2, and 9 is assigned to these variables. Now, the third line itself says Q equal to 1 plus R. So what is the value of R currently? It is 9. So Q equal to 1 plus 9 will eventually will be 10. Okay. So Q is equal to 10. So 10 will be assigned to Q. Now move to the fourth line. The fourth line will say if R plus Q, R plus Q is less than Q. So if inside the if condition, only two things happen. Either this condition written inside the if, it is false or it is true. So let's take if it is true or false, or it is correct or incorrect. Okay. So R plus Q what? R is 9 and Q is 10. So it is eventually will become 19 and Q value is 10. So 19 is less than 10? No, it is a false value. So it is a false. So when it is a false, do I have to perform this instruction which is written inside the if? No. When the if condition will return false, so we don't have to perform the instruction written inside the if condition. So here the line number 5 is being written as instruction of this if condition, but this will return me false, so I don't have to execute this one. So now I will move to the sixth line and it is written as and if. So this if condition is being added here. Now we are moving to the second if condition. So second if condition in the seventh line. So it is written as P minus R. So P is 6 and R is 9. So eventually it is minus 3. And P plus Q, it is what it is? P plus Q, it's 16. So is minus 3 is less than 16? Yes, so it is true. So when it is true, so I have to implement the instruction written inside the if condition, which is line number 8. So line number 8 will say R equal to P plus Q plus R. So P plus P is 6, Q 10 and R is 9. So both of all of them are added and the value will become 25 and this will be assigned to R. So R will become 25. Now, since this if is true, so this else will not be initialized now because if is already been initialized. So this will not be initialized and here the if condition is being ended. Now we are moving to the 12th line and 12th line will say me Q equal to P plus 9 plus Q. So the value of P is 6 plus 9 and value of Q is 10. So 6 plus 9 is what? 15 plus 10 will be 25 and it will be assigned to Q. So 25 will be now assigned to Q. And now after doing all, we are just printing P plus Q plus R. So value of P is 6, Q is 25 and R is 25. So 25 plus 25 will be 50 and 6 will be added to it. It will be 56. And you can see the fourth option, which is D option, is correct as 56. I hope you understand this pseudocode as well. Now we are moving to the third pseudocode. Okay. Now, so come here down here. So here it is written again initialization is been done of three variables. So three variable is P, Q, and R. And again, the value initialized to P as 6, Q as 4, and R as 7. Again, the third line itself is a if condition. So we have to check that if this if condition will return me true or false. If it will return me true, then I go inside, or if it is false, then I don't have to go. So let's check. The first condition is written 9 is greater than Q or not. 9 is greater than, so what the value of Q is 4. So 9 is greater than 4. Yes. So it is true. So it will return me true. But I have to check for other condition also because here you can see this operator is being used. So here two and is being used. So whenever the two and will be used together, so it is basically a logical and operator. Okay. So let me write the condition for logical and here also. Logical and operator. So it is written like this. So it will say logical and will say if both the statement which is compared by logical and is true, then return true. Else, what? Return false. So basically it means if we are checking two condition, let's say we are checking condition 1 and condition 2. If condition 1 is also true and condition 2 is also true, then overall value will become true. Then the result will be true. And if any of them are false, let's say first one is false, then also false. Let's say if second one is false, then also false. And let's say both of them are false, then also the logical statement will return me false. So in all other cases, it will return me false. So here you can see the first one is itself return me true. So now I have to check for the other one also that if the second condition is also returning me true or not. So second condition is written Q minus 9. So value of Q is 4. So 4 minus 9 will eventually get me minus 5. Is less than 9 minus Q or not? So 9 minus Q will eventually 9 minus Q will be 5. So minus 5 is less than 5. It is also true. So both of them are true. So true and true. So true, logical and true will get me what? You can see here the value as true. So I am getting the value true from this condition. Okay, let me erase this. So this will return me true. So when this if condition will return me true, then I go inside this if condition or have to instruct or have to perform the instruction written inside this if condition. So here first instruction is R equal to Q plus P. Okay. This will so R equal to P Q plus P. So Q is value is currently 4 and value of P is what? 6. So 6 plus 4 will eventually get me 10. So value is 10 and it will be initialized to R. Okay. So R will become eventually now 10. Again, go down this condition. So here the condition is been written. Again, the if condition is been written inside the if condition. Now I have to check this condition is true or not. So here the condition is being written. If 8 plus R, so 8 current value of R is 10. So this will eventually 18 plus 9 plus Q. 9 plus P will be 15. Okay, because current value of P is 6. So 18 plus 15 will eventually will become 33. So if all overall will become 33. If 33 is greater than P plus Q, so P is 6 and Q is 4, which is 10. So 33 is obviously greater than 10. So it is true. So this is a true statement. So if it is true, so we have to again perform the instruction written inside this if condition also. So it is written R equal to P plus 7. So current value of P is 6. 6 plus 7 plus Q is 4. So 6 plus 7 will become eventually 13 and 4 will become eventually 17. So 17 will be assigned to uh, 17 is being assigned to R. So now new value of R will be changed to 17. Now we are ending this if statement here. So this if will be ended here. Now we are going to move the another instruction, that is Q equal to P plus R plus Q. So P is 6, R is 17, and again P is 6. So if we add them both, so 17 plus 6 will eventually will become 23, and 23 plus 6 will eventually will become 29, and it will be assigned to Q. 29 will be now assigned to Q. Now we are ending this if condition also, and now we are moving to the next statement, that is R equal to P plus Q plus Q. So P value is 6, Q value is 29, and again the Q value is 29. So 29 plus 29 will become eventually 58, and 58 plus 6 will get you the value as 64, and it will be assigned to R. So R will now become 64. And now if we add them both, all of the value is being added and printed. Okay. So the overall value will become 6 plus 29 plus 64. And if we add them both, so 9 plus 13 plus 6 will be eventually 9, and 1 is 2 plus 8, 99. So overall value will become eventually 99. So this is the value what we are getting from here. Okay, the overall value is getting me 99. So here the option is not being provided. It is being provided to you in examination, but here the screen in the screenshot of the problem, the option is not been present, but the correct answer for this will be 99. So whichever option will get you 99 as your answer, so you will tick that. Okay. So now we will be moving to coding part. But before moving to the coding portion of this video, I would like to tell you one thing, that since the Accenture has starting their hiring for many freshers, so online study for you has bring you a great opportunity to prepare for this Accenture examination very well and crack this examination with a good marks, okay, or a good package. So for that, online study for you has bring you a Accenture crash course, which is also been provided with additional 10 free mock test series. So what it is in this crash course? So let's see the content of this crash course. So here you can see all the topics which is being asked to you in Accenture examination this year is being given in this video, in this uh, course. Here you can see the reasoning and complete previous year question is also been provided. Then pseudocode concepts will be provided. Here I am discussing some problem, but the concept to solve many problem or many kinds of problem is been provided in this course. Again, cloud and network security question is also been provided, which is a very important thing because this thing you can't find anywhere. Okay, so this is very important because there is sectional cutoff in Accenture also, so you have to do well in every section also. Now the verbal ability is also provided there, and the coding problem and the previous year coding problem or the recently asked coding problem is also been added in this course regular basis. And then above that, 10 free mock test series is being provided to you, from which you can access your or assess your what you can say uh, preparation, that how much you are prepared now or in which topic you have to prepare more. That thing you should know by giving the mock test series, which is being provided here, and there are 10 more mock test series which will eventually get you the examination friendly also. Okay, and now let's see the content or the video lecture, that how actually the video is being provided. So let me open this reasoning video only, where you can see all the topic is been covered in very detailed manner. You can see the blood relation, which is a very important topic in Accenture examination, is been covered to you in 1 hour. Again, coding decoding problem is also been covered to you in 1 hour 10-minute video. So you can see the length of the video is also very good. That means there are many problems, many types of problem is been solved in this video, and previous year's problem is also been added here regularly. And believe me, if you have exam in a week or in 5 or 10 days, then you can easily cover this all this content in just uh, 4 to 5 days, and you will be cracking this exam in very good manner. Okay, so I hope you check out this course once. I recommend you to this, and you can also see the price of this course is also very less. So I recommend you to get that course, okay, as soon as possible, so you can easily crack this examination. So now let's move to the coding problem. Now let's back to the coding problem. So this is the coding problem which is asked in the Accenture examination. So let's first read the problem statement. Okay. So the problem statement tells you that we have to implement a function which is minimum squares where an integer is been passed and as an argument. Okay. Now the function accept a positive integer n as its argument. A number n can always be represented as a sum of square of other integer. The number n will be represented as sum of squares of other numbers. Implement the function to count the minimum number of squares that add up to that n and return the count. So the problem statement will say you that you are given any number. Let's say the number is here given as 30. Okay. And this number can be getting by adding the squares of some other number. Okay, so if we have to get 13, so there are many approaches. You can see we are just adding one square plus one square plus one square up to 13 times, because every time one square will get you one. So when you add one square for 13 times, then that value will eventually get you what? It will get you value as 13. So in 13 adding operation, so minimum number of square we have to add. So to get 13 by this adding one square every time. So by adding one square total 13 times, we are getting the value as 13. Now there is one more way that we are adding one square. You can see here one square for 9 times, that eventually get me the value as 9, and then I add 2 square to them, which is 4. So 9 plus 4 will eventually will be 13. So 9 times it will be written, and then 1 time 2 square will be written. So over 10 times, in 10 times I'm getting a value 13. Okay, now one more way. So you can see every possible way is being written here to get the 13 by adding sum of square. So you can see another way is written. I can write one square for 4 times, which eventually get me, or sorry, one square for 5 times, and then two square for 2 times. It is basically two square and two square. So it is eventually in 7 times I am getting my value as 13. Now again the next will get you 13 will getting by one square 1 times, it will get you 1, and 2 square 3 times. 4 plus 4 plus 4 will be eventually getting you the value as 13, and it is in the times 4 times. Okay. Then one more possible way is that I am adding 1 square for 4 times and then 3 square for 1 times, which is 9. So 4 plus 9 will eventually get me in 5 times. I am getting my value as 13. Now there is one more way, which is I am adding 2 square plus 3 square, which is 2 square is 4 and 3 square is 9, and in the 2 time only I am getting my value as 13. So this is the all possible way by which I get my sum of square as 13. Now what I have to return? I have to return the minimum number of count of all of the process. So from of the approaches or all of the ways to get the sum of square as 13, I have to return a minimum number of ways or minimum number of value which I have to add to get that value. So you can see the minimum value that I have to add to get the value as 13 is 2, which is 2 square plus 3 square will eventually get me 13. Okay. And here you see the value is it is 1 and it is 1. So only 2 times I am adding two values, square of two values, and I'm getting value as 13. So if I have to tell the answer of this problem, I am telling him the answer as 2. So this is the minimum number of square. So that is what the answer required from you. Implement a function to return the find the count of minimum number of squares that add up to m and return the count. So this is the problem. Okay. So now let's try to solve this problem. So here what I have told you that I have to first go through the all the possible ways and then compare the count of all the possible way and return a minimum possible count. So whenever we have to go to all the possible way, then there is a concept which is required to go to all the possible way, which is recursion. So we are using recursion here. That is for sure. And if you don't know recursion anyhow, then I have already made a video on recursion on the online study for you channel in the course of coding for placement series. Then I recommend you to go there and check the recursion once, then you will understand this very well. But let's now get down to this problem. So now, how we actually going to use the recursion? So first we have to get the number of which we are have to use the value. So we are using the value of 13 for the 13. So 13. Now, one thing we have to observe. One thing, so for a recursion, we have to consider a base case. Okay, this is for sure that whenever this base case is being reached, then we have to return. Okay, and recursion is what? Recursion is a function calling itself. Function calling itself. So now one thing we have to observe here that if we are getting a value as 13, then what number of square we are able to take? Okay, what number of square we are able to take? Can we take 1 square to get this value? Yes, because 1 square will get me 1 and we are adding 1 square multiple times to get this value. We can. Can we add 2 square to get this value? Yes, 2 square will get me 4. From this, I can get this value in any way. Can we use 3 square also? Yes, we can use 3 square also. Yeah, because 3 square is 9. We can get this value anyhow. But can we use 4 square? But no, because 4 square is 16 and its value is actually greater than the value which I want. So how you get a value which is less than a certain value? Okay, we have to add some value to get one value. So we can't add a larger value to get a smaller value, because whenever we add, the value will eventually become larger, larger, and larger, larger. So we can't add to larger value to get a one smaller value. So here, till how we are till what number we are checking all our combination till this 3 square. So basically we are checking for 1, 2 and 3. All of them are of all of square is being checked. So if you observe here, so the last number is 3. Last number till we are checking is 3. And if we are going to take the square root of this 13, so it will be something 3 point something, or you can say. But if we round off it to an integer value, then it will get me a value as 3. Value as 3. Because value of 4 is first starting from 16. If we take a square root of 4, then it will be 16. If it will be 4. So we are till what number we are checking in our combination? From 1 till square root of that number, which is the number we are checking. 1 till the square root of that number. So this is the first concept we have to know. Now we know that concept. So check for 13 itself. So 13 is the number and the value which we are taking 1, 2 and 3. So for all possible approach, we are taking every values. So first we are subtracting this by 1 square. So when we subtract this 13 by 1 square, then the value will become 12. Again, we can subtract this 13 by 2 square as well, because 2 square is 4 and it is less than 13. So it will be also correct. So when we subtract 13 by 2 square, then it will eventually get me 9. And we can also subtract this 13 by 3 square also. Because 3 square is also 9, it is less than that value. Then I got the value as 4. Now for 12, what are the values we can take to subtract it from 12? So we simply take square root of 12 and it is also 3. So we can take 1, 2 and 3. So first we are taking 1. Okay. First we are taking minus 1 square. So when we're taking minus 1 square, it will get me 11. When I am taking minus 2 square, then it will getting me what? It will getting me like 8. And when I'm taking minus 3 square, then it will getting me what? It will be getting me eventually 9, 13, 12 minus, sorry, 12 minus 9 will eventually 3. Now the same thing is being applied here. So for the case of 9, when we are taking square root of 9 itself, so it will again be 3. So we are taking all the 3 numbers here also. So now 1 square is subtracted, then the value is 8. Again, 2 square is being subtracted, then the value is what? 5. And 3 square is being subtracted, then the value is 0. Again, this one also is being implemented. This also is being implemented. For this one, 4, when I are taking square root of 4, then the value is 2. So the value which I subtract from this value is either 1 or 2. Okay, so 1 square will be subtracted, then the value will be 3. And the 2 square will be subtracted, and then the value will be 0. Now again, for this 11 also, when we take square root of 11, it will again will be 3 value. That is 1, 2, and 3. So minus 1 square, it will get me 10. Minus 2 square, it will get me 11 minus 4 will get me 7. And minus 3 square will get me 2. Again, I'm taking for this 8. So when I taking square root of 8, it will get me value as 2. So I can subtract only 1 and 2 from it. So 1 square will be subtracted and 2 square will be subtracted. So when 1 square will be subtracted, the value will become 7. And when 2 square will be subtracted, the value will become 5. Again, this 3, this 3, you can see. So when I take square root of 3, the value is coming as 1. So only 1 will be subtracted. So only 1 square will be subtracted. So now value is 2. Understood this? Now again, take this for this one also. So first, let me take for this left, because whenever we are doing recursion, so first we go down to one path, then we are returning back from here. So every time 1 square will be subtracted from this path. Till how many times? Till how many times? Till this 10 will reach me 0. So whenever I am performing any operation, then I have to keep count of that operation also. I have to keep the count of that operation also. So here one step is being taken, one step is being taken, and one step is being taken. Again, this two step is being taken, 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 two step is being taken. Two step is being taken, two step is being taken. Because first step is this, second step is this. So we reach in two step by performing this path, that first subtracting minus 3 square, then subtracting minus 1 square. I am getting a value as 3 currently. Okay. So till how depth I have to go till my value of this 13 will not become 0. When this value of 13 will become 0, when this value of 13 will become 0, so what I will get? This is the base case. I have told you that I have to keep up the base case. Okay. Okay, sorry. So I have to keep off of this base case. So this base case I got now. So my base case is when n is equal to 0, then I just have to return what 0, because now there is no more step to be followed. So I just return from here. So if you observe this path, so it is second port path, this is third path, this is fourth path, again fifth, sixth. Now till how? Till 13th path. When we go to the 13th path and I got the value as 0, then what I will have to do? I will return back from here. Return back from here. I will return back from here. And let's observe the last case. What will be my last case? Let's observe this, okay? Because it is a very good problem. It is a dynamic programming problem. I am using dynamic programming in this problem also. But first, let me understand you the recursion of this problem. So now it will eventually get me 9. Then again 1 square, it will get me 8. Again 1 square, it will get me 7. Again 1 square, it will get me 6. again 1 square, it will get me 5 because I am checking all the possible, what you can say, possibilities. Again 1 square, again 1 square, again 1 square. So 5, 4, 3, again 1 square, 2, again 1 square, 1, 2, 1. And when I finally do 1 square to this one, it will get me final value as 0. So when I get the value as 0, so what I will do? I will have to also incrementing the count. So it is the fourth, this is the fifth, this is sixth, this is seventh, this is eighth step, this is ninth step, this is 10th step, this is 11th step, this is 12th step, this is 13th step. This is the 13th step. So after the 13th step, I go reach the 0. So when I reach the 0, I simply return 0 from here because I don't have to return anything because now there is no more number is to be subtracted from that value because I reached the 0. So in 13 step, I reach 0. So whenever I reach 0, so I have to count the number of step which I have taken to reach 0. So in this process, I am subtracting every value by 1. I reach the 0 in 13 step, which is the last step. Okay, you can see 13. So now I'm writing an answer here. And in this answer, I want to store the minimum possible value. I want to store the minimum possible value. So if I want to store minimum possible value or return minimum possible value in any variable, then there is a rule. I have to initialize it to maximum possible value, which is int max. So now I got one step. Now what I have to check? I have to check one thing, that the number of step which I have taken to reach 0, if it is less than the value which is stored in my answer, which is the number of step to reach the value of 0 in some other way, if it is less, the current number of step which I have taken to reach 0 in the current scenario is less than the stored whatever is stored in my answer, then I update my answer, and otherwise I have to change the value of answer. Okay, I hope you understood this. So now I got the value in 13th step. So and the value stored in my answer correctly is integer max. So the value 13 is obviously less than integer max. So I update the value of answer as 13. So this is the new approach. But I am not finished now. I haven't checked all the possible possibilities. So now I have to check other possibilities also. So what I will do, I will backtrack. Backtrack means I am backing from where I am coming. I am backing in the same way. So now I back. Okay, you can observe here. Uh, where is my pen? This. So currently, so this is one way. So now we are checking, is there any other way to get for one? Is there any other way from here also? We are checking no, because if I take a square root of 1, then there is only value coming as 1. The square root of 1 is 1. And I have checked that one possibility, because square root of 1 is 1. That means that there is only one value of square of only one value which I can subtract to that value, which is 1 itself. So I have subtracted only 1 already. So here what I have to do, I do not have to perform the same operation again. So I return back. Again, do I have to perform any operation remaining on 2? No, because 2 also have a square root of only 1, and the one value is being performed here. Again, go back to 3. Again, there is 3. 4 also, there is no other possibilities. Now we go back to 4. When we go back to 4, now when we take a square root of 4, you observe it here very carefully. Okay, so when we are taking a square root of 4, so then the square root of 4 is coming as 2. So square root of 4 is 2. That means the value which I can subtract to this 4 is either 1 square or 2 square. So I have subtracted 1 square already. I have subtracted 1 square already. But now I have to subtract 2 square as well. I have to subtract 2 square as well. So now I have been subtracting other possibility. This is 2 square from here. 2 square from here as well. So this is handled by recursion only. Okay, we will be writing the recursion code also. But I am explaining you here that so that you can understand that how actually my code will be running in backend side. So now 2 square will be subtracted from here. So now to reaching till 4, how many steps we have to run in this process? Total 9 steps. Okay. You can see 9. Total 9 number of step is being used here. So now when we go down here, When we go down to this, okay, 2 square. When we, so the value will become now 0 because 2 square is 4 and 4 will be subtracted. So now the value is 4. So now again we reached 4. Again we reached 0. And how many steps? Because still to reach here, we are using the step as we are using total 9 steps. Okay, to reach here, we are using 9 steps, and this one step is now added in this path because we are taking new path from now. So total 10 step is being followed to reach 0. So now whenever we reach 0, we again compare this with our answer. So initially our answer is 13. So now we get a new answer which is we reached in only 10 steps. So now we update our answer to 10. Okay. Again, is there any other possibility for this 4? No. So we come back and go to 5. Again, for 5, there is also one possibility, okay, that we can subtract 2 square also. In the same way, we are doing for everyone, okay? So we are checking all the possibilities. So this one also we can subtract 2 square. This one also we can subtract 2 square. And when we go to 9, then we can subtract 2 square also and 3 square also, okay? But we are doing all the same tree which we are drawing here, we have done for every possible cases. And this will be done by recursion. But if you want to see the answer, so you can see the answer is coming here only in this path, because here you can see in this path what even first step we are going to do what, we are subtracting this value. In the first step we are doing what, we are subtracting this value, and in the second step we are doing what, we are again subtracting this value by 2 square. Okay, so we are subtracting this value again. Okay, so it will be in this path we are getting our minimum possible value. Okay, so what is this path? So first we are subtracting the value 13 by minus 2 square and then minus 3 square. You can see in the two possible way I can got my answer as 0. So this is the smallest possible path. It is the smallest possible part. So this is the recursion code. I'm writing the recursion code, don't worry. So let me write the recursion code once. Let me write the recursion code once in the compiler itself. So this is the C++ compiler. I am showing the Java code as well, don't worry. But let's first see the C++ code. So here first I have to take the value of n, for which I want to take, I want to get my answer, okay? And I have to take it as input also. And then I take a variable, let's say answer, where I will store my answer. And I will pass one variable, I will pass a function in which I am solving my approaches. And here I am passing the value of integer as n. And whatever the answer it will return, it will be stored in this answer variable. And then after that, I will be returning this answer. Just simple, okay? Now let me write this approach in this solve. So int is solve, and inside this argument is n. Now first I have to write the base case. So what is my base case? That if n is equal to 0, so when my value of n will become 0 eventually, then I will do what? I will return 0 from here only, because now there is no more steps to be followed on. There is no more numbers to be taken to subtract that value, because I got value as 0. So now I will return 0, and the step which is being followed in the previous part to get the 0 will be my answer to reach 0. Okay, what I will be doing, let me take an answer as int max, or you can say not answer, let me name it otherwise int max. It will be assigned to int max. Okay, now I have to write the for loop. For loop for what? For all the possible numbers which is being subtracted to my current value of n. And how I will get all the possible value which is being subtracted to my current value of n? So the value will be starting from 1, and it will go till the square root of my current n. Okay, so whatever the current n I am working on, I will go till square root of this n. And after every increment, after every possible way, I am incrementing my I by 1. And now what I will doing here, answer equal to max, sorry, min of, because I want to get the minimum possible value, min of the answer, which is currently I have, or the function which is being returned from this phase. the recursion. Okay, solve of n minus I into I. So why I'm writing I into I? Because I have to subtract the not by the value, but the square of that value. And the square of that value is multiplying those two value two times. So I will subtract this, the current value to my n, so that the new value of n is being passed to the next recursive function. And I'm adding one to it because now I have added one more steps. Okay. And then I have, after when these two value are returning, so then I am comparing these two. Okay, and I'm getting my answer. So okay, sorry, this is not the result. It is, sorry, it is the result. And after that, what I am doing here, I am returning the final result after all the possible ways, after going through all possible ways, whatever the answer is being stored in my result, it will be my answer, and return it this from this function, and it will be stored in this answer, and it will be returned here. So let me run this for you here. You can see for 13, I am getting my answer as 2, which is a correct answer. So it is a correct recursive code. So here the recursion is being happening. Here the recursion is being happening. Every function is calling to a subsequent function. And when the base case is being reached, when the value of n will become 0, so it will be returned. And when it will be returned, it will be compared with my current value of result, and whatever the minimum will be stored in result. And after doing all the possible combination, after checking all the possible ways, whatever the value is being stored in my result is the smallest value. So this is the code. But this is a simple recursive code. And if you can see here, how many times I have to run the same code. Okay, if you write the same code in your Accenture examination, then some of your test case might be failed. Some of your test cases might be failed there, because you can see, observe, if you are here quietly. Okay, let me, if you observe here, how many times you are running the same code here. Here you can see, come down to here, we are getting to reach 8, or you can see here 3, you can just 3 or 8, any value. So what, from here it will be returned to reach 8 by minimum possible way, to reach 8 by minimum possible way. So I've already performed my function on 8 previously. So again, when 8 will be occurred, so I have to perform the same operation again in the recursion, because recursion can't hold the previous values. Whatever is written from the previous value, this recursion can't hold on to that. So there we use the concept of dynamic programming. And I have already explained the dynamic programming in the uh, online study for your website in very detail. Okay, so you go there and check that video. Now, so recursion is, so what is the difference between recursion and dynamic programming? It is the just basic thing that recursion can't hold the values which is being returned by it in following a certain steps. So, but so they, if the same path is being occurred again, then I have to perform all the paths from top to bottom again. So that is simply the waste of the time. But dynamic programming approach says, whenever you go down to any path, and whenever you are returning back, then you have to hold the value returned from there. So if again you visit the same path, then you don't have to perform the same approach again, because you already performed this and you stored it somewhere. So when again you are performing the same, you get your answer from somewhere, and return that answer. So this is the simple dynamic programming approach. So for that, what we are going to do here, we are going to take array, or okay, array, or you can say I'm taking it as vector. Vector is a dynamic allocation of array of dp, and the size of array is what, n plus 1. Why n plus 1? Because how many different value are there? So let's say if I am taking, performing my operation on 13, then what are the all the possible value which I can visit? What are the all possible value of n which I can visit? This is in the range of 13 to 0, 13 to 0. So you can see there are total 14 different values which I can visit. So that's why I'm taking 14 different array spaces. Okay. And initializing all of them are 2 minus 1. So let's take it here. Okay. So 0, 1, 2, still 13, and initializing all of them to currently minus 1. What it means to initialize all of them to be minus 1 initially? That means whenever before performing the operation in the recursion, you can say let me pass the DP from here also, so that I can access that DP in my solve function. And let me take it as argument also here, int of DP, and I am passing the reference of DP here. Okay. Now, this is the base case, it will be running fine. But before performing this operation of recursion, I am checking one thing, that if dp of n, that the current value of n which I am on to, or I am going to perform my recursion on the current value of n, if it is not equal to minus 1, what it is mean? If it is not equal to minus 1, then that means I have already performed that value, because then only the value of here will be changed to the value which I got previously from, let's say I have uh, let's say 3. Let's say take an example of 3. So I have already gone through 3. When I am returning from 3 to 4, so before returning, what I will do, I will get the minimum possible steps to reach 3, which is what? Which is 3 is being stored here, which is 3, minimum possible ways to store 3, which is 3, is being stored here. Okay. So that means this value is now currently not equal to minus 1. So that means if the value which we are checking, we are going to check in the DP array, if this value is not minus 1, that means we already performed that value earlier and we got that value. So we don't have to perform the same operation again. Just return the value whatever you stored, because you already performed the operation. So return whatever you stored from here only. And if the value is not equal to, if the value is equal to minus 1, that means we do not have perform that step yet. So we have to perform that step. So we are performing that step here. Okay. And after performing that step, whenever we are returning our results, before returning, what we have to do, just go and store that in my DP of n. So if any other time the same value will come into my case, then I simply get that value from here only. So this is a simple DP approach. So now let me run this. Okay. One thing I missed, that I forgot to pass the DP here, solve function. Okay. Here also the DP is being passed. Now let me run this. Now you can say I am getting the correct output here also. So by using this, I am trimming down my time complexity from, because the time complexity of this recursion function earlier will be 2 to the power n, because I am approaching every node n times, 2 to the power n. Every twice 2 to the power n will be the time complexity, which is exponential time complexity, which is a very bad time complexity to be write on. But when we are using the recursion approach, then we are only going every step only once. We are only going every step only once. So my time complexity will reduce to a significant value there. Okay. I hope you understand this code very well. Now let me show you the Java code for the same problem also. Okay. It is a very slightly tricky problem, I know, because the dynamic programming concept is being used here, but I try my best to explain you all the logic. But if you are not familiar with the dynamic programming or the recursion concept, then I recommend you to go and learn recursion and dynamic programming from my playlist on online study for you website, because it is a very important concept for you to know, and without knowing this you can't be able to solve this problem. Okay. So this is one approach from my side. Now you can see the Java code from the same also. Let me zoom it out for you. Okay. So this is the simple Java code. Now let me run this code again for you. Here also I'm using the DP concept. Now let me run for the same output, and I hope I am getting the correct output also from here. You can see I'm getting the correct output as 2 from here also. So I hope you understand whole the program or the logic that I try to explain you here. Now, before ending this video, I again recommend you to check out this course, because it is a very important course for you currently. For everyone who is preparing for Accenture examination, it is a must go through course for you. Okay. So now, thank you for coming this video. We will be meeting in some other videos. Thank you.